Hello everyone, welcome back to Calculus 2. So in this video, we are going to continue to talk about 1.2, the definite integral. So if you watched the video in the last time, we talk about the summation notation and how that is used to discuss the Riemann sum to estimate the area of irregular shape, right? So 1.2, finally, we are going to use the integral to find out the area of the shape. So let me take a look at the idea we just introduced in the last session. So long time ago, many people were wondering, am I able to find out the area under the curve? So let's say you have a function y equal to f of x. It could be a linear, it could be a quadratic, it could be polynomial. So let's assume that there's a function looks like the blue line. And then your goal is to find out the area from x0 to xn. So I want to find out that area, right? So everybody knows that this is not the circle, this is not a rectangular, this is not a triangle. This is not the regular shape that we have learned so far. This is like a very irregular shape, like a little bit of a curve here. And then, it's difficult to find out that. So the idea was, the ancient mathematicians, one of the guy whose name is Riemann, he discovered that, maybe we can find out many rectangulars with the equal side, right? Equal length of the side. And then it's easy to find out one rectangular's area, because as long as you know the length times the height, that's going to be the area of the first rectangular. So you can keep on doing, adding all the rectangulars under the curve, you might be able to estimate the area under the curve. So that was the very clear, brilliant idea. So we spent time finding the area under the curve by focusing on left side area or right side area, so that we can maybe estimate the actual area between them, right? So the idea was the height times the equal length. This is the height. This is the length of the each, rectangular equal length, so that you're adding all the rectangulars area with the summation notation. And then the limit and approach to infinity means that the more, the better. So if you have a more rectangular, you could reduce the arrow. So therefore, there's a limit, getting along with together, so an approach to infinity. So if you combine all this information, that's how you can estimate the under the area. So this is a very classic way to find out to estimate the area. So in modern math, we are using the integral. So whatever the information, limit and summation notation, it's a too long information, but we know what they mean. So the integral simply indicate that, we are adding all the summation of the rectangular by height times length, so that you're adding all the summation, and we assume there are infinite number of the rectangular. So that's what the integral implies. We're going to use this one, integral, and we call this is definite integral. So in Calculus 2, we're going to use that integral symbol more and more. So that's where the integral concept came from. And nowadays we are using integral instead of using, this complicated limit and summation altogether. So as long as you have, very irregular shape of the, area, there got to be a way to find out the area, right? So there's a couple, one statement to use the definite integral. So I'm going to show you that. So the next slide, here we go. We have the same definition of the definite integral. So what I'm saying is, in order to, take the integral, there is a condition. The function that you have must be continuous. Then the function is integrable on A to B. So what that means is, if you're a given function, so you could have, this type of function and you want to find out area, or sometimes you want to have very, up and down shape and you want to find out the area. So there is a same goal, you're going to find out the area under the curve. But the thing is, the function that you have, it must be continuous function, which means there's a no break, there's a no hole. If there's a hole, we fail to take the integral at the end, okay? So just check it out. If you have a piecewise function where there are two different domains, the integral differentiation will not be working, okay? So only continuous function, you can take the integral. So this is the one condition to take the integral, okay? So I will show you a couple examples how to find out the area under the curve, but I will do step by step, okay? I'm gonna build up, very step-by-step work, so hang in there. So let's take a look at the example. I hope you guys enjoying this concept, understanding this concept. So here is the example. So we are reading this question, use the geometric formula. So, geometric formula means, specifically to find out the area of the right triangle, circle, or square. But anyway, let's look at this function. Use the geometric formula to find out the area of a circle in this function. So hold on. So let me write down the Riemann sum and the more than way of the definite integral. So we know to find out the area under the curve or under the function, we just talked about it. Limit and approach infinity, summation I equal to 1 up to n. There's a height times the equal length, right? And then this one, we change it to this formula. This, Riemann sum has been improved using the integral so that a to b f of x times dx. This is the integral concept. So let's analyze it. So we have a given function here, and they're using integral, and then I guess there is a function. Oopsie. So we have, this is the function. This is going to be the height, which is corresponding to f of x, and there is a length, equal length dx. So what does it mean here? We don't know what this function look like, but if you have any function, whatever, like, I don't know, but it's a circle function somehow, and then they're looking for the area. Let's say this is 9 minus x minus 3 second. And then I want to find out the area from 3 to 6. So here, let's check the graph of the function, which is y equal to 9 minus x minus 3 to the second power with the radical. So let me go to decimal. So you can go to decimal. So we have a given function. So let me clear. We have a y equal to radical 9 minus, and what they say, the function, let me go back to that equation, minus x minus 3, close parenthesis, second power. And this is the function. This is the graph of that function. So as you see that, this is the half area of the circle. And they're looking for the area from 3 to 6. So the radius of this circle is definitely 3, right? And they're looking for the area between 3 to 6. So we checked the graph. So let me bring this image here. So let me go back to here. So what happened is I found out the graph, and they say we have actually this way. So we have a semicircle, right? This does not look like semicircle. So anyway, this is a semicircle. So this is the graph f of x equal to 9 minus x minus 3, second power with the radical, right? So we check the graph. I'm looking for the area from 3 to 6. So from 3 to 6. So we check that this is a 6, this is a 6, 0, 0, 0. That one was a 3, 3. So the radius was a 3. And then they're looking for from 3 to 6, which is this area. We're looking for this area. Okay, so let's write down a couple notes. So note, we know area of circle, the formula is a pi r square. This is a whole circle area. And then area of half circle is going to be divided by 2 so that you can find out half circle area. And then area of semicircle, what does it mean? The quarter, 1/4 pi r second. So this is going to be the half of the half. So what does it mean? This shape exactly asking you to find out the semicircle area. So therefore, by looking at the geometric shape, we can simply think of the circle formula, and therefore 3 to 6, 9 minus x minus 3 to the second dx means we are looking for the area from 3 to 6 with the semicircle. So therefore the formula is 1/4 pi r second, and then r is a given, radius is already given by looking at the shape. So 1/4 pi times 3 second. So I got 9 pi over 4, approximately 7.69. So that's the area of that semicircle. Sometimes you can simply find out the answer by using the geometric formula. This is a lucky case, right? We don't have any complicated, equation yet, but sometimes I'm letting you know we can use a geometric formula to find out the area under the curve if we have a, very regular shape. So I'm gonna keep on going. One more example, okay? I haven't talked about how to take the integral yet, but this is just, introduction of the concept of using integral, okay? Integral help us to find out the area, okay? So let's go here. Okay, we have a second question. So let me read it. Find the area under the curve. So this is the function f of x equal to 2 minus 2x second on the interval between 0 to 2. And then they create 8 rectangular between that. But as you see that, one of the, some rectangulars are above on the x-axis, and then other, rectangulars are below on the x-axis. So how to find out the area under the curve? So definitely we are looking for this area. This is the area under the curve, and then this is another area under the curve. So in this case, we need to think about it. One is above the x, another area is below the x, because the function is keep going down, 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 down. So one is look like a positive area, another one look like a negative area. So we call this as net area. How to find that? Area above the x, area above x-axis minus area below x-axis. So you can find out the net area if you have this, up and down shape. So I will show you the concrete example, with to find out the net area. So here is the example. Okay. So let's read the question. Find the net signed area between the curve. So we have a y equal to 2x. So if you graph it, this is a super linear function. So y equal to 2x looks like this. And then they say, find out the area between -3 and +3. So as you see that, there is an area above the x-axis, which is here. There's area below the x-axis, correct? So how are we gonna find out the area? So first, let's find out the area above the x-axis. So area above the x-axis. So we know that from here to here, so this is a 0, this is a 3. This is exactly right triangle, so we can use a geometric formula to find out the right triangle. So it's going to be, if you have a 3, what is the point? This is a 2 times 3 will be 6. So 3, 6, the height is a 6, the length is a 3. So we have the 3 times 6 divided by 2. So which is a 9. So this is the area above the x-axis. So far so good. I also need to find out the area below the x-axis. So as you see that this part, so that is going to be 3. The length is going to be 3. Although you have a negative, the length should be positive number. We are not saying that you are going to the left direction, negative 2 kilometer or whatever. It's a positive. Length is a positive. So same thing. This is a negative 6, negative 3, and negative 6. Height is a 6. Length is a 3. So same thing. You have 9. So now you want to find out the net area, the total area, which is above area minus below area. 9 minus 9, 0. So therefore, the net area with this function from negative 3 to 3 is going to be 0, which makes sense. So I just show you a very simple question based on the specific geometric shape, like a circle or right triangle. So if you have a regular shape with the geometric formula, it's so easy to find out the area as we just observed. But the question is, what if we have like irregular shape? Now I'm going to show you that. We have a very irregular shape, or right? So in this case, we're going to follow the properties of the definite integral. So let me show you a couple definite integrals property. So here we go. I'm gonna get rid of this one for a second. So this is going to be very important property when you have integral symbol. So here is the thing. So now we know what does it mean of the integral. So it means you are looking for the area under this particular function f of x. We don't know this f of x yet, but let's say there's a function and you're looking for the area from where to where? From a to a. So if you have integral, let's say this is the given function from a to a, do we have an area? No. So if you have an integral itself, a to a, there's no area existed. So therefore it is 0. The area will be 0. Second one, if you change the order, for example, 0 to 2, f of x dx. If you change the integral, let's say now you have a 2 to 0, but then you change the sign of that. So therefore, a to b, b to a, then you have a negative sign. So they're going to be equivalent, right? So check it out. This is the second property. Third property is the same thing, the distributive property. You can adding them up together or you can separate it. This is a distributive property. Okay, the fourth one, if you have a constant, you can always bring it into the front so that C is not going to be part of the function together. You can take it out and make it more simple. For example, if I have a to AB, 2 times f of x dx, you can bring this one to the front to AB, f of x dx. They're equal. Last one, we have a to b. So let's say you have a function and you're looking for the area between a and b. Let's say you have another point between their C. So the AB, the whole area that we're looking for is the same as this little piece plus another little piece. So therefore, A to B is the same as, right? A to B is the same as A to C, or I'm gonna write it, A to B is the same as A to C and C to B. So that's the last property you can think of. So we're gonna apply this concept to find out the answer in the following question. So maybe you need to think about this property It's not really complicating to, use. So let's really, go to the next question and check it out. So I'm gonna go down slowly. Okay, here is the question. So let's say I do have a function. We don't know what the function, but it looks like, let's say we have a function f of x, and they say from where to where? From 0 to 8. So from 0 to 8, the area is 10. That's what they mean. Do you see that? This integral help us to find out the area from 0 to 8. And then the curve, this is the function under the curve between 0 to 8. The area is 10. That's what the first information. Second, with the same function from 0 to 5, so I'm going to change the color from 0 to 5. The area, this amount is going to be 6. So we're going to keep in mind this information, and let's look at letter A, B, C. Ooh, find out the area 5 to 5. Oh, there's no area. I told you, according to the first property, if you go to yourself, there's no area, so the answer should be just 0. All right, second question, they're looking for the area, which is this yellow part, 5 to 8. So what do we know? First of all, we know from 0 to 8 with the same function is gonna be, right? It's gonna be same as 0 to 5 with the same function plus 5 to 8 with the same function, correct? So this is the last property, we just talked about it. So this is now 10, and then this is now 6. So what would be this one? That's the question mark, correct? So the automatically, it should be 4. 10 minus 6, that is gonna be 4. So that's the answer. All right, one more example. So I have a same function. So then now they're looking for the negative 8 to 8. And then they talked about it is odd function. What does it mean, odd function? Do you remember in pre-calculus, such as x to the 1, x to the 3, x to the 5, whenever you had odd power, that's the odd function. So the shape of the odd function is always right side up, left side down. So there's symmetry based on the, y-axis. So therefore, we have one of the odd function looks like this, and then they want to find out from negative 8 to 8. So which is 1 here, this area, plus the below area. So we're going to take a look at it. So what do you guys think? So we have to think about it. So 8, negative 8 to 8, f of x means you have from negative 8 to 0, f of x dx plus 0 to 8, f of x dx, correct? So we are adding those two area. So that's going to be from negative 8 to 8. All right, so here, we already know that this is going to be 10. Am I correct? And then since all the function means that these two area will be symmetry. Am I correct? So therefore, what do you guys think? This is going to be, so if you have this one is positive 10, right? And then let's think about it. This is a little bit tricky. So we want to find out that area. Okay, but we are not looking for the net area, correct? So this one still, if it is a 10, this is also 10. So therefore, this is 10. So from negative 8 to 8, the total area will be 20. Okay, so that's from negative 8 to positive 8 area. Okay, I'm not asking you to find out the net area, so we are not really subtracting this one minus that one. So the net area means like an average. It's a 0. But we are looking for the summation. So each area is a 10 and 10. So therefore, the total area should be 20. So that's the odd function. Okay, so that's we just understand how to use those properties so far. Okay, I hope everything is going well. So let's take a look at one more example. Okay, so this is the question. I want to, illustrate it. So let's look at that. What is going on? So we said, if you have, in this time, we have a specific function, x to second, x to the third. So let me draw that. What is the first one? This is the linear function. This is the y equal to x. And then from 0 to 1, the area is 1/3. So that's what I got. This is the area. And then second one, it is a parabola function. Yeah, x to the second, y equal to x to the second. And from 0 to 1, they say the area is 1/2. Third one, the function is cubic function, so that one is going up, the other one is going down. From 0 to 1, they say the area is 1/9. So the function is changing, right? Because that's the integral. We don't know what type of function we're going to have, but the integral help us. This is the definition of the definite integral. You are looking for the area between a to b, whatever the given functions under. So therefore, you can find out and analyze what they're talking about with the given information. And let's do the first one. Okay, so here, I'm going to separate it because we can use a distributive property. So the first one, from 0 to 1, 6x dx minus 0 to 1, 2x a second dx plus 0 to 1, 1/3x to the cube dx. Okay, the next property, I can bring all the number to the front. So 6, 0 to 1, x dx, 2, 0 to 1, x second dx, 1/3 x to the third dx. Okay, there's integral. So what else we know? We already have given information. This is 1/3. This is second power, 1/2. Third power is 1/9. So we can write it 6 times 1/3, 2 times 1/2, 1/3 times 1/9. So therefore, 2 minus 1 plus 1/27. 1 plus 1/27. So you will get 28/27. That's the area under this super complicated functions under between 0 to 1. So we just got it. That's how you're going to do it. Okay, so you have a better confidence, getting better and better. So we're going to keep practicing it. So just keep in mind the property. Okay. All right, let's look at the second example. So x to the second power. So we have second power. So actually, we already know this is 1/2 from 0 to 1. But we are looking for where to where? -1 to 1. So -1, +1 here. So we are looking for this area. Dun, 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 dun. This one we call the even function. So what does it mean? Even function has a characteristic such as x to the second, x to the 4, whatever the even power. The area left side and right side, again, the area left, area right, they're going to be equal because it is a symmetry. Okay, so we can do that. So -1 and 1, x second dx. It means -1 to 0 with the same function x second dx. 0 to 1, x second dx. And then we told you it's the same symmetry. We already know this is 1/2. So if this is 1/2, the left side is also 1/2. So therefore, the total area is also 1. That's it. So you can find out the area under the curve by understanding the symbol of integral. Okay, so we're gonna keep on going. One more example. Here we go. All right, so we have a function. So let me draw. Oh, actually, we did the similar work. I have a little bit typo, so this one should be 5. Just let me rewrite it. Actually, we did this question, but let me redo it. So what happened? With the function f of x, 0 to 8, they say the area is 10, right? That's what they mean. With the same function from 0 to 5, the area is going to be 5. They're looking for what is the area, 5 to 8. So same property we just talked about it. So 0 to 8, it's the same as, so if I write it everything, f of x dx, we have a 0 to 5 first, and then adding 5 to 8. So therefore, this is 10, this is 5, this one should be 5 as well. So that's your solution. Okay, the number 5 property. So 1.2, it's a very, very, very introductory of understanding the integral. I haven't shown you how to take the integral in more complicated calculation, but let's keep practicing it, right? You got the concept, what that mean integral, where it came from. So now I'm gonna do one last concept. 1.2 is a very, very short topic. So let me go to 1.4. Okay, so 1.4, we're gonna talk about the average value of the function. So let's say we have a function, looks like this. And then by using the integral, you have an interval a to b, and then you can find out the area under the curve. So that's what the definition of the integral, definite integral. So here in this area, so later we're going to talk about this one area. It could be volume, it could be force, it could be velocity, it could be in many contexts. So what I'm saying is, I want to find out the average value. There gotta be some number c that gives you the average value of the function. So how to find out that information? So simply, we know that this is the entire area from a to b with the function f of x. You're gonna just divide it by the length of the bottom. So 1 over b minus a. If you multiply that, that's going to be the average value of that function. So this formula gives you average value of the function between a and b. So I will show you the example. In this case, we're going to find out the average value in this cube. This is a cubic function. And then between -1 and 1, I want to find out the average. So let me draw that graph. Everybody know that this is the cubic function, y equal to x to the third. And then they want to have the range between -1 and +1. We already know, you can instantly feel it because 0 is 1 away from each other, 1 unit. So we already know that 0, 0 will be the average. If you hold that point, whatever this shape will be standby, like you can hold it, that's the average. But I want to prove it more mathematically by using that average function. So I'm going to use that function, the average function set, 1 over b minus a to b, whatever the given function, and take the integral. So we're going to plugging in, this is a, this is b. So 1 over 1 minus -1, and then from -1 and 1, right? And then given function is x to the third. Okay, good. So far, so good. And then let me rewrite it. It is going to be the negative change to positive, -1 to 1, x to the third dx. Here, we don't know how to find out the area, -1 to 1. So this is the question mark. This is the area. Okay. We don't know. So here, I haven't told you how to calculate this part, how to take the integral. So this is, so far, every example that I show you, it was a given. Whatever the information has been given, so you literally substitute. But now I'm not giving you what the outcome of this integral. So actually 1.3, I'm going to introduce, these are all the integral technique. Don't be scared. I'm going to show you everything later. But one of the technique is one of the basic integral technique is a number one. Okay. So if you have an integral, there is a way you can actually calculate it. So the way is if you have x to the n, so you are going to adding 1 with the to the exponent and divided by that exponent. So for example, I'm going to change to the color red. X to the third, that's the function. So according to the technique, we are adding 1, and then what is the summation? 3 plus 1 is a 4. And you're going to divide it by that exponent summation 4. So then you're going to have -1 and 1 right at the end. So let me keep writing. That means x to the 4 over 4, -1 and 1. And then a little bit of calculation. So you have a 1 and -1. So plugging in 1 first, and then subtract -1 into the x. And then if you calculate it, it's going to be 1 over 4 minus 1 over 4. This is going to be 0. So what does it mean? The area, if you're adding this 2, they say it is going to be 0. Okay, therefore, we have a 1 over 2 times 0 is also 0. So that's what information, that's our average value, 0, which is we actually got that. So average value is a 0, but this is the outcome. I want to know what x give you the outcome 0. So we want to find out what is that. What is x comma y at the moment? So the function is x to the 3. It means c to the third is a 0. So we have only option c equal to 0. So therefore, 0, 0, because when you're plugging in 0 into this function, outcome is a 0. So therefore, 0, 0 is the average point of this function. Okay, so this is the average value theorem. And then we just prove that 0, 0 is the average value. So this part might be a little bit awkward, as you see that, this part. This is what we're going to do in 1.3 video. Okay, so stay tuned. So 1.2, they just introduced how to take the integral, but I will show you more in 1.3. 1.2 is a very short topic. We are just exploring what the mean of the integral, how to find out the area with the given information. And then you also can find out the average value of it, you know, by looking at this little formula. But the real problem we're going to face is going to be 1.3. So 1.3 will be more important. So check it out. 1.2 should be good. So you can finish all the assignment and complete the, quizzes. And please, there are embedded video you can also watch so that you can increase your knowledge as well. Feel free to email me if you have any question. I will see you soon in the next video. Thank you, everyone. Bye-bye.